lecture is on 5.6, multiplying polynomials. First off, we'll start off with multiplying monomials. We'll jump right into it. Multiply the following monomials. Recall that monomials are products of numbers and variables. So here we have negative 3 and times 5x. Use the associative property and multiply the negative 3 and the 5 together first. And the result is negative 15, so we get negative 15 times x, or simply negative 15x. For our next example here, we have negative 4 times the monomial 7xy. Well, we simply, again, use the associative property. Negative 4 times 7 xy, which yields negative 28 xy. And then we have negative 12 times the monomial negative 5a squared. Well, likewise, we get negative 12 times negative 5 times a squared. Negative times a negative, positive. 12 times 5, 60. 60 a squared. Now we will multiply monomials that both involve variables. And so the first one, negative 4x times 8x. Well, you use the commutative property and the associative property to multiply the numerical factors first, and then multiply the variable components. Negative 4 times 8 is negative 32. And then x times x is x squared. Here we have, let me box that solution. Okay, so now we have 4 times negative 3, and then x squared times x squared. Now, as we learned in 5.5, the rule for exponents is to, when you have the same base, is to add exponents. So first, for the numerical factors, we have 4 times negative 3, which is negative 12. And then we have x, same base, add the exponents. And we get negative 12 x to the 4th. Then over here, we get negative 9 times negative 5. And then x squared times x cubed. Again, same base. So first we multiply the numbers and get positive 45. Negative 9 times negative 5, positive 45. And then the base is x, and we add exponents. 2 plus 3. So we have 45 x to the 5th. multiply the following monomials. And now we have multiple variables in each monomial. So first, multiply numerical factors together, like so. 11, and since we have a negative number here, we want to encase in parentheses. And then group like variable powers together with the commutative property. So you get x squared times x cubed times y to the fourth times y squared. And that is negative 33. X to the 2 plus 3, 5. And y to the 4 plus 2, 6. And for our next example, well, again, group numerical factors, 4 times 5. You don't really need the parentheses like we have here when the numbers are positive. You should include them when they're negative so you don't mistake it for a subtraction. 4 times 5, and then x cubed times x to the fourth, then times y to the fourth, and then times y to the seventh. And 4 times 5 is 20. And then x to the third times x to the fourth, we get x to the 3 plus 4. And then times y to the 4 plus 7. And we end up with 20x to the 7th, y to the 11th. All right. And then here we get 7 times negative 15, a to the 5th times a to the 7th times b to the 4th times b to the 5th. 7 times 15 is 70 plus 35, so 105. And then a to the 5th times a to the 7th is a to the 5 plus 7. And then b to the 4th times b to the 5th is b to the 4 plus 5. And then we get negative 105, a to the 12th, b to the 9th. Well, our next topic is multiplying monomials and polynomials. And so here we have a monomial. Here we have a polynomial with 4 terms, degree 3. And we need to use the distributive property here. The distributive property holds when there's more than 2 terms. And we want to use arrows to indicate that we're multiplying the outside monomial to each term of the polynomial in parentheses. So outside we have negative 2x, which then multiplies to everything inside. So we get negative 2x times 3x cubed. And then negative 2x times 2x squared. And then negative 2x. See, when the monomial is negative, just carry that negative through. Negative 2x. Now this term is negative, so it's critical to use parentheses. Negative 2x multiplied to negative x. Lastly, negative 2x times positive 2. All right. Now we simplify, combine like terms, if any. No like terms, so it doesn't look like, so we simplify. And we get number times number. And x times x cubed. And then we get negative 2 times 2. So we can write this as minus 2 times 2. And then x times x squared. Here we have negative 2 and no other number, so x times negative x. Well, x times negative x, we can put in parentheses and arrange the negative x first so it doesn't look like subtraction using the commutative property. So this negative x times this x. So it's kind of the commutative property and associative property all at once here. Then negative 2x times 2. So we have negative 2 times 2 times x. And then negative 2 times 3 is negative 6. And x times x cubed is no exponent visible, so it's a 1. Then plus the other exponent, 3. Negative 2 times 2, negative 4. This is x to the first times x squared, so x to the 1 plus 2. Here we have negative 2 times negative x squared. You could combine this all at once and do negative 2 times negative x squared, or in steps, keep the negative 2 out here and do the multiplication inside here. Well, x times x is negative x squared. Both exponents of 1, you add the exponents, you get 2. And then here, minus 2 times 2 is minus 4x. Now we have negative 6 x to the fourth. And then negative 4 x to the third. Negative 2 times negative 1, positive 2, x squared, and then minus 4x. And that is our answer in descending order for this multiplication here. Okay. So now we have 3ab squared times the polynomial 3a squared minus 2ab plus 4b squared. The first step, as you recall, is to draw our distributing arrows to signify multiplication of the outside monomial to each monomial inside. Then we have 3ab squared times 3a squared. And the operation's minus, so we can write the minus first and then the 3ab squared times the 2ab. And then plus 3ab squared. I need a little more room. Times 4b squared. So we get 3 times 3 times a squared times b squared, then minus 3 times 2, a times b squared times b, and then 3 times 4 times a times b squared times b squared. Which results in 9, and then a cubed, because this is an exponent of 1. 1 plus 2, we get a cubed, and then b squared. Next term, negative 3 times 2, minus 6. A times a squared. B squared times b cubed. Then it's plus 3 times 4, 12. A, b squared times b squared, b to the 4th. And that is the final answer. Notice that it is conveniently in descending powers of a. Without us having to do any further rearrangements.